Students, today in this class we will discuss about the complex number representation and the square root of the complex number. You have got the first video, the introduction of the complex number, that the representation of the introduction of I and omega. So what is a complex number first? I want to show you that what is a complex number. A complex number is the combination of a real and imaginary part, the imaginary number. A complex number, let us take Z is a complex number, I say. I can write it as X, which is real part. Imaginary part is I into y. Here this is the real part and this is imaginary part. Real and imaginary both combined together to give the complex number z. Z is equal to x plus iy. That means example minus 3 plus 2i, 2 minus 3i, 3 plus 2i. Okay, then I can write minus 3 minus 2i. These are the examples of the complex number. The complex numbers are written in the form x plus iy. X plus means it minus 3 into I. Here plus 2i, here it is also plus of minus 2i. So any complex number is written in the form, either in the form x plus iy, where x is the real part and y is the imaginary part. This is the representation of the complex number. Now, how this can be represented? Using graph. Actually, the complex number is represented in a graph, in a plane. You know, plane is a region bounded between x as well as y axis. So, the plane which represents a complex number is called Argon plane. In the Argand plane, x-axis will be the real axis and y-axis is the imaginary axis. This is real axis and this is imaginary axis. X-axis is the real axis, y-axis is the imaginary axis. That means if I say 3 plus 2i, so x is having 3 and y is having 2, what we have studied, and the complex number notation is 3 plus 2i. Like this, if I say minus 3 plus 2i, you can see this is minus 3, the plus 2. So it is minus 3 plus 2, so answer is minus 3 plus 2i. Okay? Similarly, it is, I can say here, minus 2 and minus 3. 2 and this is 3. So minus 2 minus 3, this point. What is the complex number notation here? Minus 2 minus 3i. Similarly, if I say this is plus and minus, plus, it is minus. Let us take 3 minus 2. Answer is 3 minus 2. The complex number notation is 3 minus 2. I am writing here 3 minus 2. Thus, we can represent a complex number in the Argand plane. That means Argand plane is nothing but a real axis and the imaginary axis bounded plane. Real axis is x-axis, imaginary axis is y-axis. Only you find out the points on the respective quadrants. 2 minus 3. It is 2 minus 3 means 2 minus 3. 2 minus 3, it is plus minus. It will lie in the fourth quadrant. So answer is 2 minus 3i. If it is 3 plus 2i, that will lie in the first quadrant. 3, 2. 3, 2 is the point and its complex notation is 3 plus 2i. When it is 3 plus 2i? When it is represented in the Argand plane. Okay? Then pause the video to note it down. Now you will see how to find out how to represent the complex number in various form. That was in the Argon Plane. Now you represent the complex number in the various form. You see how this is represented. Let us take a point P, x, y here. Then the complex notation is x plus iy. You should remember this is real axis and this is imaginary axis. The z is equal to, you are writing x plus iy. You see, if I join this OP, let us take this is R. Then we can write here, this is x now, this is y. We can write, if this angle is theta, then cos theta is equal to, we can write cos theta is equal to b by h, x by r. Cos theta is equal to b by h. What about, that means x is equal to r cos theta. Similarly, sin theta is equal to y by r, implies y equal to r sin theta. Therefore, we got the complex number which is z, which is x plus iy. I can write r cos theta plus I r sin theta. So, a complex number z which is written in the terms of theta as r cos theta plus I r sin theta. If I can take common r, so that is cos theta plus I sin theta. Cos theta plus I sin theta is written in the Euler form as e to the power I theta. We can write it as e to the power of I theta. It is called Euler form of the complex number. Euler form. What is Euler form? That cos theta plus I sin theta is the Euler form of the complex number. So this is the representation of the complex number in form of x and y. This is the representation of the complex number in form of theta. Now what is r? You will say, sir, what is r? R is nothing but root over of x square plus y square, Pythagoras theorem. R equal to root over of x square plus y square. Here R is called the modulus of the complex number. R is called modulus of complex number. Modulus of the complex. Okay. R is called modulus of the complex number. Then what is theta? What is theta? Theta is called argument of the complex number. Theta is called argument of complex number. Then how theta is obtained? We get tan theta equal to y by x. Tan theta equal to y by x. So what is theta? Tan inverse y by x. If we know the value of y and x, then we can find out the value of theta. Theta is equal to tan inverse y by x. Tan inverse is another function. If tan theta is y by x, then theta equal to tan inverse y by x. If it is sin theta equal to something, then theta is equal to sin inverse. It is another function which will be studied in the second class. Theta equal to tan inverse y upon x. Pause the video to note it down. Okay, we will take a question. Expression of 1 plus I in Euler form. Now I am going to express 1 plus I in the Euler form. Let us take 1 plus I. writing the complex number as 1 plus I. We will take the complex number 1 plus I. Then you see how to express 1 plus I in Euler form. Meaning is that how to express in terms of theta. What you do? You see x is 1, y is also 1. Root over x square plus y square. Multiply and divide with it. Again, multiply root over x square plus y square and divide. Multiply and divide by root over x square plus y square. Root over x square plus y square, meaning root over 1 square plus 1 square, it is root 2. Multiply root 2, divide root 2. Then root 2 into 1 by root 2 plus 1 by root 2 into I. You see, if this is your theta, if this is cos theta, you are getting 1 by root 2. Cos theta is 1 by root 2. And sin theta is also 1 by root 2. Then we can say that sin theta by cos theta is equal to 1 by root 2 by 1 by root 2, it is 1. Implies tan theta is equal to 1. 1 is equal to tan 45 yani pi by 4. Represent in terms of pi. Tan theta is equal to 1 is equal to tan pi by 4. So what is theta? So your answer would be here root 2 into, it is cos theta, I can write it as cos pi by 4 plus I sin pi by 4. Root 2 into cos pi by 4 plus I sin pi by 4. So what would answer? Root 2 into e to the power I theta. This is the Euler form of the complex number 1 plus I. You got it, I think? We will take another question. Before that, pause the video. Now, another question. Express 1 plus I root 3 in Euler form. We will write the complex number 1 plus I root 3. Now, multiply and divide by root over of x square plus y square. X square 1 square, y square root 3 square, root over. Multiply numerator and denominator, you can say by or multiply by root over a square plus b square. So root over a square plus b square here, 1 square 1 plus root 3 square 3, 1 plus 3 4, 4 root over 2. That means we are multiplying by 2 and dividing by 2. Okay. Then 2 into, this will be 1 by 2 plus 1 by 2 I root 3. You see 1 by 2 I root 3. Or I can write I root 3 by 2. It will be better, right? You see, you will take this as cos theta as half. Yes, imaginary part would be taken as sin theta. Real part would be taken as cos theta. Then sin theta is equal to root 3 by 2. If I divide sin theta by cos theta, then answer is root 3. Or tan theta is equal to root 3 is equal to tan. How much? 60. Tan 60 equal to root 3. So answer is 2 into, it is your theta, we are getting theta is equal to pi by 3. No? So 2 into cos pi by 3 plus I sin pi by 3. So answer is 2 into e to the power of I pi by 3. Got it? 1 plus I root 3 in the complex form. If I say right, how you represented 1 plus I root 3 in the complex in the Euler form? Let us express 1 only in the Euler form. Express 1 in the Euler form. How 1 is represented in the Euler form? Express 1 in Euler form. Express 1 in the Euler form. Is 1 a complex number? Is 1 a complex number? Yes, 1 is a complex number. How? Real part is 1, imaginary part is 0. That means I can write here cosine 0 cos 0 1 I into sine 0. 1 is equal to cos 0 plus I sin 0. Or you can write it as e to the power I into 0. I don't want to say because if I0 is 1, so this will be the representation of the 1 in the Euler form, e to the power I0. Yes, write it, there is no problem, e to the power I0. E to the power I theta. Here theta is equal to 0 because of 1 is equal to cos 0, sin 0. But remember, students, if I say cos theta, its meaning is that you must remember cos theta is equal to cos 2k pi plus theta. Remember this concept, cos theta is equal to cos 2k pi plus theta, and sin theta is equal to sin of 2k pi plus theta. You must remember these two concepts. What is cos theta and what is sin theta. Here k stands for 1, 2, 3, 4. That means sin 2 pi plus theta is sin theta. Cos 2 pi plus theta, cos theta. Cos 4 pi plus theta, if I say k is equal to 2, then cos 4 pi plus theta is cos theta. Sin 4 pi plus theta is equal to sin theta. You must remember these two things till the complex number is completed. Complex number complete, that till the complex number is going to complete, you must remember these things, that cos theta is equal to cos of 2k pi plus theta, sin theta is equal to sin 2k pi plus theta. So I can write it as 1 is equal to, I can write cos 2k pi, because of theta is 0, 2k pi plus 0 plus I sin 2k pi plus 0. So answer is cos 2k pi plus I sin 2k pi. Okay, so 1 is equal to getting cos 2k pi plus I sin 2k pi. Here you must write k is equal to 1, 2, dot, 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 dot. 0 will start from 0, 0, 1, 2, dot, dot, dot. I think it is clear to everybody. Pause the video to note it down. Next is to find the square root of a complex number. Let us take a complex number x plus iy. Its square root would be another complex number. It will be a plus ib. Then if I find the value of a in terms of x and b in terms of y, because we know the value of x and y, so if I find the value of a in terms of x and b in terms of y, then our answer would be complete. Then what to do? Square both sides. Squaring both sides, so you are getting, if I square both sides, then x plus iy is equal to a plus ib whole square. A plus ib whole square, a square plus I square b square plus 2aib. Its value is x plus iy is equal to a square plus I square is minus 1, because we know I is equal to root over minus 1. In the first video I have completed about the properties of I think. We know that I is equal to under root minus 1. If you have not watched that video, then watch the video so that you will get I is equal to root over minus 1, how it is obtained. So I is equal to root over minus 1. Square is I square minus 1 only. I square is minus 1. Minus 1 into b square, it is minus b square plus I into 2ab. So we write x plus iy is equal to a square minus b square plus I into 2ab. If I say these two are complex number, you see, this is a complex number and this is also a complex number. In this complex number, this is real part, and this part is your imaginary part. The part which is attached with I is the imaginary part. If two complex numbers are equal, then a real part would be equal at first. A square minus b square would be x, and imaginary parts would be equal. So 2ab is equal to y. A square minus b square equal to x and 2ab equal to y. If we know the value of a square minus b square and 2ab, can we find a square plus b square? You see how this will be obtained? So under root a square minus b square whole square plus 4a square b square. You see, from where this property or from where this identity obtained, we know that a plus b whole square, there is a formula, a minus b whole square plus 4ab. If I replace, it is a square and it is b square whole square, then it will be a square minus b square whole square plus 4a square b square. You see? Thereby, I can write a square plus b square equal to under root this one. So, a square minus b square is x square. Here, 4a square b square is 2ab whole square, 2ab whole square, 2ab whole square. Isn't it? So, it is y square. The root over. Right? We got a square minus b square as x. Come to this side. A square minus b square equal to x. And a square plus b square is equal to, writing x square plus y square root over. If I add them, minus b square plus b square, 2a square equal to x plus root over x square plus y square. So what about a square? It is half x plus root over x square plus y square. What about a? A is equal to under root half x plus root over x square plus y square. We got it, I think. You see? This is your value of a. How to find the value of b? A square plus b square, we are taking root over of x square plus y square. A square minus b square, we are getting x. If I subtract these two, then a square minus a square would be cancelled. So 2b square equal to, we are getting minus x plus root over x square plus y square. What about b square? B square equal to 1 by 2 into minus x plus root over x square plus y square. So what about b? Under root half into minus x plus root over x square plus y square. So what is that value of root over x plus iy? The root over x plus iy is equal to, here you have got the value of a and here the value of b, so I can write root over of half of x plus root over x square plus y square plus I into root over of half minus x plus root over x square plus y square. It is clear to everybody? Then pause the video to note it down. Then shortcut method to calculate the square root of 3 plus 4i and to calculate the square root of 5 plus 12i. You see, why I have taken these two numbers? Because these two numbers are the complex numbers having real part is even number. This is the imaginary part is even number. Imaginary part is even number. 4 is the imaginary part here, 12 is the imaginary part here. Alright? If it is even number, then divide by 2. 4 by 2 is 2. I am proceeding with this question number 1. Okay? 4 by 2 is 2. Then find the two numbers so that on addition there would be 3, on addition there would be 3 and on multiplication there would be 2. On multiplication 2, addition 3. Okay? On multiplication it would be y by 2, on addition it would be x. That means the numbers are 2 and 1. 2 1s are 2, 2 plus 1, 3. Now I am going to adjust here, you see, like this. Root over 3 plus 4i. I can write 3 as, you see, we have taken 2 and 1 now. I can write 2 square, 4. It is 1 square, 1. So 4 minus 1 is equal to 3. Okay. Then 4i, I can write 2 into 2 into 1 into I. Right? 2 into I. Yes? You can observe this one. 2 into 1 is 2. 2 into I. Then what would happen? It is 2 square. It is I square. Because minus 1 square means 1. Minus 1. Minus 1 is nothing but plus I square. Then it is plus 2 into I. The root over, you see. Quite easiest method. So 2 square plus I square plus 2 into I. Answer is a square plus b square plus 2ab. The answer is a plus b whole square under root. Isn't it a shortcut method? But this method is applied only when the imaginary part is an even part. Next you see, if I say 5 plus 12i, 12 by 2, 6. 12 by 2 is 6. Then after multiplication it would be 6 and after addition it would be 5. Then what would happen? After multiplication it would be 6. On addition it would be 5. So it is 3 and 2. If I replace here, 3 square is 9, 2 square is 4, 9 minus 4, plus 3 into 2 into, is 3 into, you see, 1 minute here, 2 into, 3 into, 2 into, root over. That means we are getting 3 square minus 2 square minus 4. Minus 4 means it is 2i whole square. You see, 2 square is 4, I square is minus 1. 4 into minus 1, minus 4. Plus 2 into 3 into 2i under root. Answer is 3 plus 2i whole square under root plus or minus 3 plus 2i. How you have done it? 12 by 2, 6. The numbers which would be multiplied together would be 6. So 3 and 2 would be 6. I mean that I have to grasp whether the minus here you see 3 square is 9 and 2 square is 4. 9 minus 4, it is 5. 9 means it is 3 square. Minus 2 square is minus 4. Minus 4 is nothing but 2i whole square. Because of 2 square is 4, I square minus 1. I am writing here 2i whole square plus 2 into 3 into 2i. So answer is 3 plus 2i whole square. The answer plus or minus 3 plus 2i. Okay. You practice all these questions and the fundamentals so as to excel in the complex number. And in the next video, I am going to solve some more questions on the square root as well as the other roots of unity. Next video will be our nth root of unity. Keep watching. If you are new to my channel, then subscribe it after pressing the bell icon. Okay, you will get all the notifications of this channel, and share with your friends so that they would also be benefited. Okay, thank you.